Today we are going to see one of the non-linear data structure, that is the graph data structure. And there are the lots of real-time applications of the graph data structure. Like we can use a graph data structure we are using in the real life Facebook. Each user is represented as a vertex and two people are friends when there is an edge between two vertices. And similarly, different applications like Google Maps, recommendations, and you can see in networking also we are using the graph theory. So today we are going to understand the concept of the graph, and after that we will move towards the implementation of graph in the Python. Hello everyone, this is Sharda from GoEduHub Technologies, and I would like to welcome you all for this session DSA with Python. And today we are going to see one of the non-linear data structure, that is the graph. Okay, so first we will understand what is the graph, different type of graph like directed graph, undirected graph, weighted, unweighted. Okay, and after that we will go ahead and then we will see the implementation of the graph, and we find like there are the two different paths. We can find the minimum distance path, and we can find the path between two destinations. Okay, so am I audible, guys? Okay, so now we will start the graph. First thing comes to mind is what is the graph and why we use the graph. Okay, so as I told you, graph is a non-linear data structure. Okay, so let me write here graph. It is a non-linear data structure. And it will have certain nodes and edges. Graph is something like this. There is a certain points like A, and then A is connected with the B, and B is connected with the C, and C is connected with the D. Something like this. Or you can say E. Okay. So here these A, B, C, D are the vertices. A, B, okay, and edges. This is a edge, this is a edge, and this is a edge, and this one. So these are the edges. You can say edges is AB, and then BC, CD, CE, or DA. These are the edges. There are the different real-time applications where we are using the graph behind the scene. Like inside the networks, we are using the graph. Network maybe include the path in a city, or telephone network you can say, or you can say circuit network. So in the real life, you can see there's some example. One is the networks. Okay, and second thing is, second application you can understand, that is the Facebook. In the Facebook, we are connected with some friends. Okay, so like I'm connected with one friend and my friend is connected with the another friend. So Facebook is providing you to suggestion you may connect with the friend of your friend. So each user that having a profile, okay, is a vertex. Okay, and two people are friend, they are connected with the edge. So two people, I can write here, connected with edge. Okay, and like similar friend suggestion you are getting, that is also using the graph theory. friend suggestion. Okay. And some more applications like Google Map. In the day-to-day life, we are using the Google Map in every application. Third application I can write here, Google Maps. Like Google Maps we are using when we are booking some cabs. So cabs also providing the location, and we can see they are connecting with the different drivers, and then they will tell you the nearest driver, will assign a nearest driver to you. So basically various locations are represented as a vertices. Location you can say as vertices. Okay. And the routes is basically edges. And similarly, the fourth application I can say the recommendation, like recommendation over the e-commerce websites. When you are searching for some item, it will recommend you some other items also. Okay. So these are the certain real life applications that we are using in day-to-day life, and they are basically using the data structure that is the graph data structure. Guys, this is the 20th session, and till the 20th session I have told so many times how to mark the attendance. Okay, so through the social media network, our social media pages, Facebook and LinkedIn, where we are updating daily assignments, you need to answer those there. Then and below this YouTube, whatever the class video, YouTube video, you have to write the session summary. That is the way. So this is the simple applications of the graph. Now we will come to topic what is the graph and how we can understand and how we can implement the graph in Python. Okay, we got certain applications here. Okay, like in this one you can say there are the different type of graph. This graph I have created here, this is undirected graph. Like your Facebook friend suggestion is a undirected graph. And like this maps, in the Google Maps we can say the road map, I told you the location maps. So you can apply a application like the flight routes and bus routes, train routes, you can find out. Okay, so let me come to this. I'll open the new file. Now we will see the different type of graphs. Okay, type of graphs. In a simple graph we have edges and vertices. That is the thing. We are having certain edges and we are having certain vertices. Now we will come to different type of graphs, how we can represent different type of graph. Now we know what is the graph. Okay, so I can say one of them is directed graph and undirected graph. Undirected. Okay, in the undirected graph there is no arrow over the edges, like A connected with the B, and you can say B connected with the C and C connected with the D, and simple. Now I can write here the another type of graph, that is the directed graph. In the directed graph we will have certain arrow. So you can see our A's have some way, like path would be from A to B only, not B to A. Okay, so in the directed graph, we are connected all the edges with a direction. Okay, here edge is having some direction. And here all the edges are bidirectional. Okay. Like in the Facebook, we are connected with our friends, so we can share the things among in the both way. Like we can share the photos, we can share the comments, we can share the things among each other. That is the undirectional graph. And for the directional graph, you can see the Google Maps, like flight routes. This is the directional graph. Like from Delhi to, one flight is going from Delhi to Mumbai, Mumbai to Kolkata. So it have some direction. Okay. Third type of graph is, you can say, weighted. Like in this directional graph, we can have certain weight. Like for the distance, I can say A and B and C. Okay, this is a graph, and these A's is having some weight like 5, 6, something like this. So you can say, in the case of routes, you can say distance from A to B is 4 kilometer or something, some value. That is some meaning we are having. Okay, like A's is having certain values, and that values are associated with the A's. Okay, these weights may represent some speed or it may represent some distance. Like you can say speed in between B and C, it can be speed, it can be distance, it can be something else. For in case of network, I can say this is a speed of data packet in a network, or you can say bandwidth of a data packet. Okay, so this is basically different type of graphs. Now we will see like how we can represent the graph. We can represent the graph with the help of adjacency matrix. Okay, like I can show you here the sequential representation. Like this is a n-directional graph, A, B, C, D, E, something like this. And from this graph, I can say I will write A, B, C, D, E in columns and A, B, C, D, E in rows. We will create an adjacency matrix that will show the path in between A and B, like A to A, B, C, D, E. Similarly for B to different nodes. So we will write here the path. So for A, you can say path is A to B and A to D. So for A to B, we will put 1, and A to D, we will put 1. Others, we will keep 0. Similarly for B, you can see path is B to A, B to D, and B to C. So B to A, we will put 1. B to C, we will put 1. And B to D, we will put 1. So we can create a matrix. Okay, this is for undirected graph. Similarly, you can see for the directed graph, like A to B, C, D, E, something like this. Here you can see the direction. So here we cannot write the path from B to A. We can write the path only A to B. So A to B is 1 only. B to A is 0. B to C is 1. B to C is 1. Okay. And similarly for the weighted graph, like this is a weighted graph. Here in place of 1, we will put the weight of the edge. Like A to B, we will put the weight is 4. So this is the representation. Okay, and there is the two way of representation. This is the simple linear representation, and other way is kind of linked list representation. So in the list representation, we are putting like this: A to B, A to path where we are having B or C. So A to B and B to D, something like this. Like path from A, we will write all the points. So this is the representation, simple. Now what we need implementation in the programming way. Like we just want to write a program for the graph. Okay. So I'll create a graph here. A location graph. I'll create a location graph. Okay. And I'll create a location graph like this. Here I'll write Jaipur, and from Jaipur to, I'm writing some flight, can be Jaipur to Mumbai, flight or train, you can write anything, and from Jaipur to London. Okay, and there can be a flight from Mumbai to London. Okay, and there can be a flight, okay, from Mumbai to Paris, and there can be a flight from London to Paris. Okay, and I can write some more things. Paris to Canada. Something like this. I'm just writing the randomly. Okay. So this is a graph. Control Z. This is a graph I have created. That is the route graph. Routes I have defined. So there is a different nodes. These are the Jaipur, Mumbai, London, Paris, Canada. All these are the nodes. Okay, these are my nodes. And these are the edges. And there can be a path between two nodes. So, like I just want to go from Mumbai to Jaipur to Paris. If I'll create a tree, in the case of tree, there is only one path from, like, what happens in the tree. It is enhanced version of the tree. In the tree, we are having certain nodes and we are having one path only. Something like this. Okay. But here, in a proper way, here we can connect in vice versa in the reverse direction also. We cannot connect like this in the tree. But in the graph, we can connect in any way. Okay. So basically what happens, I just want to go from Jaipur to Paris. So there is the multiple path. Jaipur to Paris, I can go via Mumbai, I can go via London. Okay. So one way is Jaipur and then Mumbai and then Paris. Another way is Jaipur, London and Paris. Another way is I can take Jaipur and then Mumbai, this way, Jaipur, Mumbai, London, Paris. Something like this. There are different ways. These are the different paths. So similarly, you are using some cab service and you just want to go from one destination to another destination. You just booked a cab from Jaipur to Kolkata. So what happened? This cab can go in this cab can take different path. Okay, so it depends on, and that path having some distance, like weights. You can say here you can put certain weights like 5,000 kilometer, 8,000 kilometers, something like this. So we can take the different path, but we just want to find out the shortest path. Okay, so here we can do the different ways. In the implementation part, what we can do, we can find the path between 2 points. One way is find all the path, all the possible path between 2 points, and we can find the shortest path between two points. Similarly, same thing we can do with the networks also. Like in your college, you are studying in some college, there is a network. Okay, and that network is taking how many hops from one location to another location. You can count the number of hops. So that is also using the graph data structure. So let me write this thing in the implementation part in the Python. Okay, so how we can write the Python code? Like we have to write a class. Okay, so these basically these are nodes. These nodes are, we will have certain nodes and we will have certain ages. So these ages a pair, ages having a pair. So we can create a list of pairs, list of different nodes pair. Like I can create a list of Jaipur and Mumbai. Okay, and I can create a list of Mumbai and Paris, something like this. This is a list of these nodes. Basically, this is my root, or you can call it ages. Okay, so let me write the Python code. Are you getting what the problem we are going to solve? How we are going to implement the path? Graph. Guys, till now everything is clear. Can you please confirm me? Like, are you getting the things like what is the graph, different type of graph, and different real-time applications of the graph? And now we are going to do the implementation of graph in the Python. And if you have any doubt, you can ask me. Otherwise, I'm going to write the code that is the simplest code. We will implement with the help of Python. So Google Colab, and in the Python, I just create a class. Okay. So here, first of all, I'll define a class, or I can write my roots. Ages equals to, and I'll create a list of all the ages in the form collection of tuples. Okay, so I can write like this, what the cities I have taken: Jaipur, Mumbai, all the possible combinations I'll write. Jaipur, Mumbai, and then Jaipur, London. First is okay, and second collection is Mumbai to some location. What is that? Paris and London to Paris. Mumbai to Paris, London to Paris, Mumbai to London. Okay. And one more, Paris to Kolkata. I'll write the Kolkata in place of Canada. That is very long path. Paris to, we just want to back in India. So Kolkata. Okay, that's all. This is my list. Ages list. Okay. Next thing is what I will do. I'll define a class. I'll create a class for the graph. That will create a graph. Okay. So class graph. Okay. And inside this class, inside the class, what we define always? Something wrong. Yes. Okay. We always define a constructor. Okay. Init. And inside this constructor, what I need to write? The self and then ages. Okay. And ages I'll define like this. Self dot ages equals to ages. This will create your graph. Okay. We are going to find out all the path. And after that, we are going to find the shortest path between two stops. Like when we are visiting different websites, you just want to book a ticket for the train or flight, you will visit some website and you will go, you will put your source and then you will put your destination. The websites will show you the different path, like you can go via this flight, you can go via this flight. You have to choose. Okay. So what we need to do here we need to write some more things. We don't want to use this list. We can write this list in the format data structure. And that data structure is graph. How to convert this list into a graph data structure? So we will create a dictionary. And in the dictionary, what we will do, we will put like inside the dictionary, we will put a key like Jaipur. So values all the path, all the destination from Jaipur to the flights we are having from Jaipur to other destinations. So we will put all the things. Like I'll create a dictionary here. We are not going to use this list. This is the simple list I have written. But for the data structure point of view, I'm just going to implement the graph data structure with the help of dictionary. Okay? In the Python, there is no graph data structure. So we will use dictionary. And inside the dictionary, what I will write here, I'll write a key and then value. So like here, first I'll pick a key like Jaipur. Okay. So for the Jaipur would be my key. And for this, I'm going to write a value inside a list. So from the Jaipur, where I can go? I can go Mumbai, I can go London. Okay. One is the Mumbai and another one is London. Similarly, Another key can be Mumbai. Okay, so here I'm just going to create the another key is Mumbai. And the path from Mumbai to you can go Paris, Mumbai to you can go London. So here I'll write the values Paris and then London. Okay, and next key I'll create the London. And from the London, where you can go? You can go only the Paris. Okay. Similarly, we will write the another thing, that is the Paris is left out, right? Unique city's name is 1, 2, 3, 4, 5. Paris. From the Paris, where you can go? From the Paris, you can go only Kolkata. Okay? This is the dictionary. We are going to use this dictionary. Basically, we are going to create this type of dictionary with the help of this program. Okay? This is the thing I just want to tell you. I'm not writing the manually. I just want to create this type of dictionary with the help of the graph. Okay? So here I have to write certain codes. Inside this constructor, I have to write certain codes. Here first I'll define a dictionary. I'll create an empty dictionary. Self dot graph underscore dictionary equals to empty. I'm taking an empty dictionary. And then I'll write a loop here because this is a list of tuples. This bracket having the tuple. So I just want to extract the tuple, unfold the tuple. So for the unfolding the tuple, this tuple having two things. One location is start point and end point. So here I'm writing a loop for, and then I can write here start, comma, end in self dot ages. Okay? And like this is a tuple, first value will come inside the start and the second value will come inside the end. Okay? So what we want to do, we want to make this start as a key. Okay? And end would be its value. We just want to create a dictionary with the help of these two values. So there can be two things. First, I'm creating inside the dictionary, there is no key. So first thing is there is no key, and if key is already existing, like the first time I visited the Jaipur, Mumbai, there is no key existing Jaipur. But next time whenever I'm visiting this thing, Jaipur, London, it means Jaipur should be there exist, and we have to only append the value London in the key. So I have to create the dictionary like this. Okay. So two conditions I have to write. One is the if this is already present, and else. Like first condition is if start is in self dot dictionary, self dot graph dictionary. Then we will do some work. Okay, and one is the else part. if it is not existing, like first time I'm visiting any tuple, then what I will do? I will make this as a key, start as a key and end as a value. Okay, so I'll write here self dot graph underscore dictionary. Okay, and here I'm writing start equals to end, or end I'm putting in a list. So basically what it will do, first time Jaipur and Mumbai comes, it will check it is inside the dictionary. No, dictionary is empty, so this condition not satisfying. It will go inside the else condition, and in the else condition we will make start as a key and end as a value. So first time it will create a dictionary that will having the key Jaipur and values Mumbai. Okay, now if second time Jaipur and London, so it means now the key Jaipur is existing inside the dictionary, graph dictionary. So what we can do here? For this we will append the value, that is the end value, to the dictionary value. So here we will write self dot graph underscore dictionary, and start, it will check the key is already existing, then we will append end. Okay, now we will print our dictionary. Even you can print inside the loop, print inside loop graph underscore dictionary, and same thing we will print outside the loop, so that complete dictionary will be printed. Self dot graph underscore dictionary. Here also I need to write the self. Okay, and how I can call this function, this constructor, I can call this constructor by creating the object for this graph class. Okay, so I'll create an object of this graph class here. Okay, path, you can write graph path equals to, my class name is graph, and inside this I'm passing ages, so I'm calling this constructor. Okay, this is my class, and inside the class this is constructor. I have to pass the ages. So here the graph object I have created graph underscore path. So let me run this code. Okay, so here you can see first time what happens, we are creating inside the loop. This is the output of inside the loop. The first visit, this first tuple Jaipur will be a key of the dictionary and Mumbai is value. When second time we are visiting this Jaipur London, so Jaipur is a key and Mumbai and London is values. London is appended a value, and next time we are visiting Mumbai, Paris, so it will check the Mumbai is already key. No. So it will create a new key Mumbai and put the value Paris. Similarly, it will create a complete dictionary, that is the output in the last. And this dictionary is equals to this D dictionary that I told you. Okay, so we have created a dictionary, or you can say we have created a graph, and for the graph, the implementation of the graph, we have created a dictionary in Python. Okay, next thing is what I have to do. I have to find out all the path between one start point from one source point to one destination point. You can say, I just want to find out all the path from Jaipur to London. Or you can say from Jaipur to Paris. I just want to go from Jaipur to Paris. So what are the possible ways? Different path. So for this, I have to write one more function. Okay, inside this class, I have to write one more function, that is for getting the path. So here, I'm defining one more function for getting the path. Okay, get path. And inside this function, what I have to pass? First parameter always should be the self. Second parameter is source point, that is my start point, and third parameter is my end point. From a destination, from a source to a destination, I just want to go. Okay? And inside this, I need to write certain conditions. Like what the output I want. You can come to here. I just want to go from Jaipur to Paris. Okay, I just want to go from Jaipur to Paris. So I want all the path for Jaipur to Paris. There would be one path. There would be one path like this. And there would be one path like this. So 3 paths I am having. Now I have to calculate the path. How to calculate the path? How to get the path? So recursively, like I can start from here. Okay? Start point is start is here Jaipur. Start you can say is Jaipur and end you can say is Paris. Okay? But when I am going to the Mumbai, from Jaipur to Mumbai, again Mumbai to London is one way. So I have to search out all the path from Mumbai to Paris. So that time my start change. So recursively I have to call. I have to get all the path. Start is Mumbai. That time also my end is Paris. Similarly, start can be my London. Like from Jaipur to Mumbai I can go, from Jaipur to London I can go. And there is the different ways from Mumbai to Paris and London to Paris. So I have to search out all the ways. When I'll stop, like recursion, for the recursion you have to write the stop condition. So where I can stop? When my first path is I'm taking, first time my start is Jaipur and end is Paris. Second time here when I'm from Jaipur to I'm going Mumbai and London. So my start can be Mumbai and end is Paris. And another my start can be London. Okay. And my end can be Paris. These are the combination. And after this, my start can be like from here to I reached here. So now my start can be Mumbai and end can be London and can be Paris. When I reaches to the Paris, that time my start and end both becomes Paris. Because like from here I'm reaches to here, it means start is London, end is Paris. And here also start is Mumbai, end is Paris. But when I reaches here to the Paris, it means my start is Paris. I don't want to go ahead to the Paris. I have to stop here. So my start is here Paris, and I know end is already is Paris. So this condition becomes means when start equals to end, equals to end, then I have to stop. I have to return empty. There is no path after this. One condition I should write this. And another way can be like there may be some city name. I have given some city name, like I just want to go from Delhi to Paris. My start is Delhi. Okay, and end is Paris. So for this I have to check the condition. What the condition? I need to check out either the start is from this dictionary or not. So this start is belonging to the dictionary or not. If it is not belonging to the dictionary, then I can say I'll return empty. So some terminating condition. Otherwise recursively I'll find out all the possible path. Okay, so let me write here the code. I hope concept is clear. Now I'll write the code. And one more thing, I have to pass here the path. Like initially I'm taking path is empty. Why I'm picking the path? I'll tell you. And path is like I just want to calculate the path. So I just want to go from Jaipur to Paris. So in the path start point is Jaipur. So whatever the start point, I have to add to my path. Okay, so here I'm writing path equals to path plus start. And sometimes what happen, I just want to find out a path from Jaipur to Jaipur. So start and end is equal. That time what I will return? I'll return simple path, that is my start point. Means start and end is equal. I told you one condition. Start and end is equal. When you reaches to the Paris, it means start and end is equal. That time you have to return Paris and you don't need to go ahead. You don't call recursively. Okay, so we have to return the current location when our start and end is equal. Okay, so here I'm writing one condition. If start equals to end, then I can return here path. What is the path? Path is the start point. Like if you are passing the Jaipur and Jaipur is start and end is Jaipur, then you will return path is Jaipur. Okay, and one more condition I can write like this. If start not in graph dictionary, start not in self dot graph dictionary. Okay, that time I'll return empty. These are the two conditions. Okay, and now I'll calculate the path. So for calculating the path, I have to visit all the nodes from the dictionary. Like this is my dictionary. Okay, in this dictionary node is Jaipur. I just want to find out the path from Jaipur to Paris. So my dictionary key is Jaipur. So I need to visit all the nodes inside the value. So for this I have to write a loop. Like for loop, I'm writing a for loop, and in this for loop what I need to find out, I need to traverse every node. Like first I'll traverse Mumbai, then I'll traverse London. So here I'm writing a loop. Okay, And initially path variable paths equals to empty. I'll return the path inside this. Okay, so for location, okay, in self dot graph underscore dictionary. Okay, graph underscore dictionary, and here I have to pass the start. Okay, particular key. At a particular key, I just want to visit all the nodes, all the values in a key. Like the key start is Jaipur. Suppose start is Jaipur. So here Jaipur, the value at Jaipur is Mumbai and London. So first in the location comes Mumbai and then it will comes the London. Okay. So this loop is for this, and inside this I need to write a condition. If location, okay, not in path, then we have to traverse. Okay, this location not in path. Okay, initially in your path, what we are having, like we are talking about the Jaipur. So initially in the path, what we are having only the Jaipur. And here the Mumbai comes. The value at Jaipur is, first value is Mumbai. So Mumbai not in path. If it is not in path means it is not visited. This location is not visited. The path of this location is not visited. So we are calculating the new path. New path equals to, recursively we have to call here get path. Self dot get underscore paths. And inside this I have to pass the location. Okay. For this particular node, for this particular location, I have to recursively call the get path. Okay. And here why we are passing the path? Because if anything is already inside the path, like Jaipur is already inside the path, so we will pass the path here. So Jaipur is already inside this. And after this, what we will add? Path plus this Mumbai. So Jaipur plus Mumbai. Two things will be added. Okay. And this will give you one path, new path. This will return one path. Because it will terminate either at this condition, either at this condition. So it will give you one path. And like this, we will get the lots of path. So all the path we will append to our new list, that is the paths. All the paths. So here we will write a loop. Okay. For like p in new underscore paths. Okay, whatever we are having inside, we are getting as a result of the path, we will append to the paths. Paths dot append p. And at the end of this function, we will return path. Okay. This is the function for getting all the possible path from one location to another location. Okay, let me call this function we have created the object. Okay, and now we will write here start equals to Jaipur. And end we are putting here Paris. Okay. And now we will call this function get path. So we will print here print possible path from start to end. Okay, And here I'll write the object is graph underscore path dot, what is the function name, get underscore path, right? And inside this, what I have to pass, start and end. And let me run this, and I'll uncomment this print I don't need, because this is giving lots of output. Yes, this is first is complete dictionary output, and second is, you can see the possible path from start to end. One is the Jaipur, Mumbai, Paris. Okay, another one is Jaipur, Mumbai, London, Paris, and then Jaipur, London, Paris. These three paths we already calculated. Jaipur, Mumbai, Paris, Jaipur, London, Paris, Jaipur, Mumbai, London, Paris. So it is giving you all the possible path. In place of Jaipur, Mumbai, you can write here Jaipur, London. And I am changing. And this time you can say two paths, Jaipur, Mumbai, London, Jaipur, London. You can see here Jaipur, Mumbai, London, and Jaipur, London. Two ways. Are you getting the things? Till now everything is clear, guys. Can you please give me the quick response? Like this, we can calculate all the possible paths in a graph. Even we can calculate the shortest path also. For the shortest path, what we can do? Simple thing, we have to write one more function, and in that function, what we need to check out? We need to check out the length of the path. Like here, we are getting two paths in this case. So shortest path is, one is the Jaipur, Mumbai, London, and another one is Jaipur, London. Obviously, you can see here Jaipur, London is shortest path. Okay, so we can calculate the length, and according to the length, we will return the shortest path. Same thing, all other things are the same. That you have to do by yourself. Get the shortest path. That is your assignment. Okay? So I hope most of the things that about the graph I'll try to cover as introduction. Yeah, it's a little bit complicated data structure, but it is not as much complicated that we understand. It is very simple. You can understand very easily. And there are the different applications that we are using in day-to-day life. So we should know the graph. We should solve certain questions based on the graph. And you will get the good understanding when you are writing the code by yourself. Okay, so I think this is enough for today. If you have any question till now about the graph, you can ask me. And like you just want to sit in a good company interview, then there would be question from the graph. There can be a coding question, and like first you will understand the basic concepts of the graph, and then you will solve some coding problems that are the best on the graph. Okay, guys? So, thank you so much. And Don't forget to complete your assignments, your attendance part. Like yesterday's class attendance is already available to our different pages, Facebook and LinkedIn, and you have to write the session summary below the session. So complete those, and we'll see you tomorrow. Okay, bye bye. Thank you so much.